Audio looks good. All right. Okay. To avoid infinity mirror. Excellent. All right, so I'm just going to try it this way, and then let me just double check again. Okay, that looks good enough. We're going to go with it. Okay, so I think everything is working. Y'all see me here? I'm recording. Everything's good. All right. Well, hello, everybody. Welcome. This is Hello Go, subtitled Hello World's Greatest Hits. And I'll get some more about that in just a second. But there are useful links here. So if you go to beyondcodebootcamp.github.io, you would find, actually that link just went directly here, but you would find there's a link called presentations, and then there's a link, the link's not there yet, but it will be very soon. So there's the Hello Go presentation right there. So if you'd like to follow along, it's beyondcodebootcamp.github.io/prezos/hello-go, and the actual link will be there probably by the time anybody is watching this recorded. And yeah, the video URL will go here as well. And there's a template repo that I created for this that I will update with any errata that we encountered during this presentation. I'm AJ O'Neill. If you want my safe tweets, it's @_beyondcode. And if you want my unsafe videos, it's youtube.com/coolage86. I'm a dangerous wrong thinker, an equal opportunity offender, as pretty much everybody in the room is already aware, and a technophobic technologist, which basically means that I think most technology is evil, is going to lead to our doom. Go is not one of those things, amazingly. I run Utah Node.js, Utah Rust, and that's why I don't attend the Go meetups as much, because I got my hands kind of full. And then I live stream on Twitch TV, Coolage86. But I love Go. This is the irony, is that I love Go. I love Go in a way that Go is part of my soul that I found. It already existed, and then I discovered it, and it was amazing. I love Go. And and last thing, as part of introductory stuff, if at any time you find this as useful or entertaining, consider like, sub, follow, etc. Okay, so Hello World's Greatest Hits. What do I mean by that? What I mean by that is this is going to be a Hello World style survey of the world of Go tooling, because the language of Go is very, very small, as a language should be. And the standard library of Go is all you need in most cases, as it should be. And then there's the extended standard library, and there's the tooling, and we're going to take a survey of some of that. So basically all the little things from func.println to Go Releaser. And if you don't know about Go Releaser, does anybody know about Go Releaser already? Yes, this is good. So if you want to make things available to the world, if you're going to publish something, Go Releaser is the way to do it. So this is going to be a whirlwind getting up to that point. Okay, so we're going to cover all these types of things and more, not in this order because I didn't go back and update this. Okay, so the 0th part of this that we need to start with is why Go? And most of you in this room have some inkling of why Go, because you're here. But I'm going to share my story, and it's a very simple story. Predictable, reproducible, guaranteed. This is why Go. Go is the software engineer's dream because it gives you predictable outcomes that are reproducible across computers and teams, and it's guaranteed. If it doesn't do that, that's a bug. That's not we're not implementing that for Windows. That's a bug, okay? That is one of the things that I love about Go, and like I said, it's smallest. So, and it's cross-platform. Kind of wrapped up in that. So, Hello Go. We need to get Go installed. And so if you go to install Go, there is one tiny little detail that's very unfortunate, is that most likely you're on a Mac or on Linux as a developer, and possibly on Windows, and your install options that are presented as the featured downloads are all bad options. And the reason for this is problems with Mac OS PKG and problems with Linux ecosystem. And so you end up getting something that is going to be a lot better than what you would get from, say, apt, but is going to come into conflict with other system stuff. Fortunately, Go has this nice automatable JSON for its list of downloads. So you can actually get the tarball in a scripted fashion and then update your path and be on to the races. I'm not going to go into that in great detail, but just to high-level overview, PKG screws up your permissions on your user local directory, and then if you install, say, Go and Node, then they fight over the permissions, especially when NPM is involved, or if you've got some other thing that you've installed via PKG. They start fighting at the operating system layer for permission grabs. And then Brew, if you've used Brew, well, one, Brew is not available on Linux or Windows, and two, if you've used it for any length of time, you've probably had the libSSL problem where weird things like curl or SSH stop working because Brew puts things in system paths and whatnot. So if you wanted to just do this in the conflict-free way, all you need to do is untar the tarball to local opt, symlink, libs and bins, and then update your path and you're good. And I created a tool that uses the JSON that we just looked at, grabs it, and then does exactly that. It's called Webby. So if you're interested in installing Go this way, which also you get the benefit of being able to switch between Go versions like that in a conflict-free way. So that's just a little thing, not really related to the core Go tooling. And then somehow this got here in the wrong place, so we'll skip over that. But if you want to run a Go thing, you can just go run whatever.go, and you can treat it just like a scripting language, and that's really fun. So here's the first fun thing to know about Go is you can just treat it as a scripting language. You don't need a directory. You don't need anything. You can just run Go as scripts, and that's pretty awesome. So it makes a nice replacement for Python if you want that predictable, reproducible, guaranteed. So the next thing that we have, aside from Go itself, which there's also some other things that we're slides are out of order, and we'll find them shortly enough, I'm sure. So I talked about the extended library. So Go has a lot of great tools and extended library features, and they're found at golang.org/x for extended, or perhaps for experimental. I'm not really sure. I guess it's
experimental.
Yeah, but I like to call it extended because it's not very experimental. It's not like experimental in other ways. You've heard the context experimental. Especially the tools are extremely stable. So but they don't fall. These are things that do not fall under the mainline Go 1.x compatibility guarantee. They can have their own versions and change, but a lot of these things do get brought into the standard library eventually. Anyway, enough about that. So you basically have three types of things. You've got automatic tooling, stuff that you probably installed without even realizing you installed it, just because it's going to be included with any sort of IDE setup, whether you're using Vim or VS Code or whatever it is. You're going to get Go Please, PLS, the language server, Go imports, which formats your imports, and then a Go doc, whether or not you use it locally on your computer, anytime you publish a Go package, it automatically gets parsed into Go doc. And then you've got, so that's all the stuff that's just automatic. It's happening in the background. You may or may not even know that you have it. Then you've got your dev utils, things that you would be using on purpose, quite possibly with something like Go generate. So things like Stringer. Has anybody used Stringer? So if you create enums in Go, they're kind of C-style enums, but you can get them to behave a little bit nicer with Stringer. I won't go into what Stringer is actually, but it's one of the most common tools that developers use in the tools library that they use on purpose. Then GoDoc, if you want to actually build the documentation and publish it yourself, not just automatically what gets published to the Go documentation website, but say you had some private packages, you would run the GoDoc tool yourself to be able to create that HTML directory. And then Embed is something that used to be done via Go generate style, but now is done automatically. So I put a little asterisk by that, but we'll talk about that later because that's one of the great things about Go is, we'll talk about it when we talk about it. And then the third thing that you have out of this is your special purpose libraries. If you just look through your dependencies, I would say these three things you'll probably find quite frequently, because all of the cryptographic libraries that haven't necessarily been around for the last 30 years or that aren't NIST approved, they kind of end up in X-crypto. There's a lot of networking stuff that, especially with the way Google works, building HTTP2, then HTTP3, and all the different things they're doing. A lot of those tools are under that package. And then syswindows, because on Windows you have to deal with things like the registry. So a lot of tools that need to store config files, where on Mac or Linux they would store it in the config directory. On Windows they might store it in the registry, and so it needs that. So again, I'm not going to go into depth on any of these. Just you'll probably see these, and that's kind of what they represent. Okay, so this should have been titled Hello IDE. So whether you're using Vim or VS Code, there's just a bunch of tools like the ones that I mentioned that you're going to want to get and install. And there is, I did make a simple little installer every time I set up a new machine, which is all the time because I use DigitalOcean and I like to develop in the environment where things are going to be deployed, rather than developing a local host and then finding out, oh crap, there's all these problems with cores and security policies and all this stuff that doesn't work when I actually get it on a server. And so every time I spin up a VPS, I just run this command, and that's why I use Vim, so that I can be on VPSs, and it installs those tools. And then with Vim Go specifically, it's in VS Code is just going to ask you, do you want to install the Go tools, and it's going to be the right stuff. But once you get that, then you open up a new file that's a .go file, and it's pre-populated for you. And whenever you save, the imports automatically adjust. And if you've got as long as the normal stack is there, you just get all of this benefit from the tooling giving you hinting and autocompletes and so on and so forth. Okay, so now that we've talked a little bit, you install Go and the something else, and somehow we got to number 4. You get your IDE set up. So this is what the anatomy of a Go package typically should look like. It should probably have most of these components, depending on what it is. If it's an application, it should have most of these. So you're going to have your package. Let's call that hello. It's going to have a .get. That's pretty self-explanatory. .ignore, which we'll talk about later. Go.mod and go.lock. We'll talk about all these things later. I'm just presenting them. You're going to have maybe a library file that has some stuff that you expose publicly, as well as maybe any assets that you need to bundle if you've got a web server or if you've got a command line tool that can initialize a config. You've got maybe multiple commands. I think that it's a real pity, I'll talk about one specifically later, a real pity that more tools in the Go environment don't take advantage of the fact that you can have an unlimited number of commands. So if you have very specific configurations, you don't need to have one command that does everything. That kind of goes against the Go philosophy. So you can have lots of commands under your, and this is, most of this is common convention. I don't know that it's necessarily in the Go book that you must do it this way. Some of these you must. Internal, that must be there. Migrations would be common convention. Tools is common convention. We'll go through all this stuff in a minute. But this is kind of, if you just had an empty project that was a complete hello world, it would probably have all of these files and folders in there. And then vendor for your dependencies. So let's talk about the module thing that I was just mentioning. So when you, I don't know why that says S on there. That was supposed to just be 1. So you do go mod init, and then you give it a git-ish, URL-ish thing. And this is what your module is structured after. So this is the name of your module, and your specific package is whatever the last thing is. So foo. Does anybody need more? By the way, feel free to cut in at any point with questions. If I'm going too far or too over the head or anything, stop me, because I don't really know. So feel free to ask questions. But are people familiar with GoMod init? Okay, almost everybody. So that cool. So that I won't spend too much time on then. And then you would need to run GoMod tidy for it to populate your dependencies, because typically you're writing a little bit of code, you're prototyping something maybe, and then you run go mod tidy, and it'll populate your go.mod to have the correct versions of the things that you're actually using. Okay, so we create a project. It's just a directory. We do go mod init, and then we're going to see that it created the go.mod file. Like I said, it's URL-ish, gitish. We understand that. Okay, so now this is where the S was supposed to be here. Hello modules, plural. This is what I was talking about earlier. You can have multiple Git modules, even in this, multiple Go modules, even in the same Git module or submodule, and this can help limit dependency hell. Go tries to do this for you. It tries to be really, really good about being lean, but there are some times that because of the way that you've structured your project, maybe because of you have a non-standard way of doing tests, maybe you have a test directory for integration tests or an examples directory. There's just, I'm not exactly clear how it happens, but you'll get mountains of dependencies in your go.mod that actually have nothing to do with what you want to export to people. And then sometimes those start to trickle down into the modules folders, and then primary offender, Golang migrate, you end up with 200-300 megabytes of dependencies for something that's reading text files and doing an insert into a database. So you can do go mod init at different levels of your package, and that will scope the dependencies to that level of the package if you find that you're in the situation where you're getting superfluous numbers of dependencies when people use your package. So just the primary offender of this that makes me so sad, whoops, let me just click on the go.mod. It was, like I said, go migrate. So there's all this stuff, CockroachDB, Spanner, WinIO, PGCon, GitLab, Mongo. Obviously, if you're running a SQL migration tool, you're going to be using one or two technologies. You're going to be using a storage engine technology, probably the file system, 9 times out of 10, which is probably going to be Go Embed. And then you're going to be using some sort of database technology, probably Postgres or SQLite. And as this project grew, it broke from the Go philosophy and started doing everything for everyone. And so now when you vendor this, you end up with, like I said, hundreds of megabytes. So just something to be aware of so that you don't create that problem for people. Okay. So next thing is Go has a philosophy, it has creeds, it has a belief, it has values. And a lot of these are encapsulated in this book that is available on the website. Very short book, it's a booklet. I don't think that it's available in printed form, but it's called Effective Go, and it explains how to name things, how to do package architecture, especially if you're coming from a terrible language like the worst of all, C++, or maybe not quite as bad, but factory Java. You'd want to read this book because it will help you to not smash your head with a hammer, because you'll learn how to do things in a Go-ish way so that you are not fighting against Go thinking, why can't I create factories? Or why can't I do 7th level inheritance polymutex? It's because Go wants you to not have to deal with those things, and it provides simpler alternatives, and they're explained here. Anybody have a comment on that? Anybody dealt with that coming into Go? Yeah? Okay. All right.
We have a lot of former Java developers who started at Weave that are all overall Go. It's a lot of unlearning of don't bother.
But
always the way you think it is.
Yeah, I equate it like the transition from Windows to Mac. Everybody hates transitioning from Windows to Mac until they get about 2 months in and they realize my problem was that I was looking for a settings menu with 7 levels deep of something to configure when it was literally all I had to do was use 2 fingers on the trackpad or something like that. And then there's the Go Proverbs. I've created a poster for the Go Proverbs so that you can print it and frame it. I literally have this printed and framed, and then use it in code reviews and cite G1, G17, whatever, when you're looking at, okay, is this Go-ish code? And so Rob Pike gave the talk. The talk is excellent to listen to. There's the website, and then there's the poster, which the website is just kind of like the poster, but less printable. And yeah, so just all of these good ideas that if you don't understand these ideas, definitely watch the talk, but just kind of like let them seep in, because the biggest part of Go is the belief system and the philosophy, the simplicity, the elegance, the letting go of things that are complicated, the making, in the face of ambiguity, refusing the temptation to guess and just waiting it out, let and see. And to that end, I have a bunch of, about half of these are Go resources about software engineering. Some of them are from people from other languages, including, I think I have one from a C++ guy on there, Titus Winters, who inspired parts of Go. But if you want to check out some more software engineering philosophy generally, creedsofcraftsmanship.com is that's where I keep my curated list that I update on a weekly to monthly basis. Anyway, so next, let's talk about the internal folder. Oh, first, any questions on that segment there? Philosophy of Go? No? Okay. So next, I just want to talk about the internal folder, because this is basically where you should start your code. Your first bit of hello code should probably go in internal, because internal is where stuff goes when you're not ready to commit to v1.0. If you can't say, I know this is right, I know this is what we should be exporting out to the world, then pretty much it goes in internal. And so non-exported, it works for non-exported peer packages, meaning anything within your package can access anything in internal, but nothing that uses your package can. So it's kind of like private, but it's not private, because the lowercase private in Go means that something even within your own package can access it. And uppercase means that something outside of your package can access it, but the internal folder is reserved for that use case of being able to prototype and experiment with your code without having to commit to a definite exported interface. So it works on, it's for whole packages, not for files. It's for things that are experimental or unstable, and that have internal implementation details that just shouldn't be exposed, or like I said, things that are kind of private. So next we have the tools directory. And this is a common convention. This is not canonicalized, but has anybody ever had the problem where you depend on something like Go Migrate or Stringer or some other tool that's out in the community, and you go and run code that has been building just fine, but when you run Go Generate, it breaks? Anybody had that experience? Maybe because the Go community is a lot more mature after 10 or 15 years. But what the tools package allows you to do is it doesn't get built, but it gets tracked, so that if you are using somebody else's code or tool, typically things that are used with Go Generate, you can put them in here and they will be locked to that specific version. So you will never have the problem of going to run some sort of tooling tool and have it break on you and not build. And since nobody's encountered that problem in the room, I won't spend too much more time on that. And that's the end of it anyway.
Like mod.sum is like a Toml and Rust or whatever. It locks to a specific version for everything you have.
Yes, but this will do this for your tool dependencies, because your tool dependencies are never imported in code.
I see.
So sorry, I didn't communicate that well. But this is for tool dependencies, like, for example, if you wanted to lock the version of Stringer that you're using, you would do this. And the underscore says, despite the fact that this is a binary package, ignore the fact that it's a binary package. I'm importing it, but I'm not importing it. And then the Go build tools, I think this is actually now, is that plus build? No, they changed it to this. This is the new one. Okay, so this tells it only use this when the tools flag is enabled. So since you're never going to turn on a tools flag, this will never get built. But because it is a flag that could be turned on, it will get included in the go.mod, or the go.mod and the go.sum. And because you're telling it to ignore the fact that it's a binary, and because it never actually gets included, it tags the version of the thing without actually giving you the error that, hey, this is a binary. So it's just it's a tooling tip and trick kind of thing.
It's like a dev version of scripting stuff or whatever, like dev tools as opposed to like things that people will use with your package.
Yeah, so you use it for you when you build and deploy. Other people don't use this. Okay. So anyway, I probably spent too much time on that because this is maybe something you're less likely to come. I've run into it, that's why I include it. So the other one is the vendor directory. So the vendor directory, we have this because it makes our builds predictable and reproducible and guaranteed. So that's like why I like having the vendor directory. Now, Go already has a lot of tooling. Every time you run a Go install or every time you run a Go mod tidy, Go actually hits its proxy for Git packages, and then it stores the SHA sum of whatever Git version of the thing that you're installing, so that it guarantees that if somebody were to just commit info-side and delete their stuff off of GitHub, this doesn't protect you. The vendoring protects you against that. But what the Go proxy doesn't protect you against that. It protects you against cases where somebody does a supply chain attack where they publish over a previously published tag. So say there's 1.1 was already published, and it knows a lot of people depend on 1.1. They gain access to the repository. They force push over 1.1 with bad, vulnerable malware. The Go proxy protects against that, but having the vendor folder protects you against that, as well as InfoSide, where people just delete their GitHub. And the way that you do this is very simple. You just do go mod tidy and go mod vendor, and then there you are. Now, depending on the version of Go, the way that I've always had to do this, which I think has been entirely obviated at this point, you used to always have to do -mod equals vendor whenever you did your Go generate or your Go build or your Go funct or any of that. I think that nowadays, as long as your vendor folder exists with a modules.txt inside, I think that it knows to do that automatically. Anybody correct me on that? Okay. So yeah, so mod.vendor, you may or may not actually need to do that anymore. And then there's the .gitignore, I mentioned this earlier. So one of the things that really sucks about vendoring is if you're using ripgrep or other search tools to find files, they'll go into the vendor directory and they'll find lots of matches for things like net or create or whatever. If you use the .ignore file, and this is just common across coding tools, and you put in your vendor folder in your ignore file, then tools that respect the ignore file will respect the ignore file, and they won't do their searches down there. So a lot of times you don't want to put vendor in your gitignore because then it wouldn't be committed and then you wouldn't have actually vendored anything. But you do want to put it in your .ignore so that it's not ignored by Git, but it is ignored by other tools that would do the searching and stuff. Primarily, I do this for the benefit of ripgrep. Does anybody use grep in here? You're living below your privileges. And I mean that in the most sincere way. Ripgrep is, once you use it once, you'll immediately understand the benefit of it. It requires almost no explanation. Ripgrep?
Oh, they're amazing.
Yeah. I don't even use the plugin for it. I just use it from the command line.
It's the same. They're great.
Yeah. It's just a lot faster and it does all the things that you expect it to do, and it respects .ignore. So let's talk about Go generate for a second. So this is what a Go generate looks like. And I use the stringer again because that makes sense to use stringer because we've already been talking about stringer. But basically, you can create a generate.go where all of the code that you need to produce, if it's you need to be reading in SQL files and generating your structs out of those, if you're using an older tool like GoBin Data or VFSGen or anything that is doing those processes that are generating code for you, then use Go generate, and it just becomes the first line of a file, and you can basically just have an empty file at the top level of a directory where things are supposed to happen. And then the way that I do it is they use go run. So rather than just running stringer, which would require that anybody using, so if somebody was just going to go to GitHub and git clone my project, if they didn't know that they needed to install stringer, they wouldn't have stringer installed. So then they'd have to add into the README. Make sure you install stringer, which means that means that they have to have their go bin path set up correctly. Maybe they don't. And so that introduces all of this fallibility. Whereas if you use go run inside of your go generate and give it the exact path, and you've got it vendored, then you can guarantee that for other people who aren't you, who aren't on your computer, all they have to do is clone the repo, run the normal Go commands, and everything just magically works. They don't have to know how you set up your development environment. So that's a thing there. Oh, and this just pains me. I see people use makefiles in the Go community, and it makes me physically ill, because makefiles are not cross-platform. They don't work on Windows, and they require you to have typically the whole GCC toolchain. I mean, good luck installing just the make stuff and having it work the way that the author expects. So huge dependencies, and this is what Go generate does. So anytime you hear someone say make, that shouldn't smell right, and you should think go generate.
Unless you're in C or C++. That's fine.
Well, yes, because you wouldn't be using Go.
Yeah. Anyway,
But we've got a solution for that a little later on too, perhaps. No, even a different solution. A different solution. So then we've got the command directory. I kind of already talked about this, so I'll just kind of skim over it. But you can have as many commands as you want. You can have multiple files in your different command subdirectories. So in your hello directory, if hello is the binary that you're building, you can call it main.go. You can call it hello.go. You can have whatever you want.
I think in every one of those folders, when you run go install and insta package, those all get installed and go in. Right? There's standard for this. So if it's a folder specifically under CMD, and you do go install, my package.github, whatever, those all get stuck into the go bin.
That might be something newer that I'm not familiar with. The way that I'm accustomed to doing it is that you would specify the full path. So I would do go install github.com/example/hello/command/hello.
Oh, maybe you're right.
That's what I'm familiar with.
Okay.
/dot. I think Go will enumerate some packages. All of them.
Let's see people do. You're right. I think you do CMD dot.
For explicitness sake, I would prefer to list them out unless there's 100 of them. And if there's 100 of them, I have to ask myself other questions. So Go migrate should be split out into about 100 binaries, and that would be a good thing, and you'd only need to install one of them. Anyway, so yeah, not much more needs to be said about that. So this is what your main file looks like. So now we're actually at the point of this is your hello world code. Well, we showed some earlier with the Vim Go example, but so this is what your main.go might look like in any of those. And then again, this is how you can build it. So you just use go build, and then you give it the output name of the binary that you want, and then you give it the directory name that has the Go files that will build that binary. All right, so now let's talk about GoDoc, because we're at the point where we prototype something and we got it kind of working, and now we need to document it. So there is a doc.go that you can put big, huge blobs of text into. So typically, GoDoc is just, you kind of comment things more or less the way you naturally would if you have your IDE, you just clicked accept on install the Go tools, you'll get these complaints that say, hey, you don't have a comment for this thing that was exported. And if you put the comment in the wrong format, it'll say this comment's in the wrong format. But the doc.go, to describe your whole package, can be really robust. And there's GoDoc tricks. I will point you that direction to learn specifically about how you can do the code blocks and have runnable Go playground examples and all that stuff. But I just want you to know that such a thing exists. And if you want to have great documentation like the Go documentation, or basically anywhere that you see, Go Doc Tricks. That's the link to check out. And also, I forgot to put this in there, but anytime, what is it? package.go.dev. Is that what it is? So you just put any Go package URL after pkg.go.dev. And if it's the first time you ever visit that package, it might take it 15, 20 minutes to get it into the queue to generate its documentation. But as long as it's ever been visited before and it has a git tag version and a license file, this is something I didn't show at the beginning, but Go packages require a license file or the documentation will not build. Because if you do not specify what copyright it is able to share the documentation, it assumes that the documentation is under a restrictive copyright and it won't build and you'll get an error message. So I forgot to mention that earlier. But anyway, yeah, you can just throw basically any Go package after this and you'll get wonderfully beautiful documentation. So for example, Go Doc Tricks. Now this one really only has a doc.go, but you know, and everybody's familiar with this site, right? Okay, so just I'll skip beyond there then. Okay, so let's continue on. So versioning is really important because again, predictable, reproducible, guaranteed, right? This is a little snippet that I like to use when I show how to when I want to let people see the version of a thing. And basically, there's four different ways that people might intuitively think that they can see the version of something. BSD style, original Unix style, is -V. The Go style is typically just to use the word version, but also is a single dash in the word version. And then typical Linux GNU style is to do -- version. So if you use a little snippet like this, I'm saying if the first argument is either -V or its version after I trim any leading dashes, then go print out the version. Strip prefix? I'll update it later. I'll make a note. Yeah. It'll be. I'll fix it and put it in the errata because I had this in another place. I didn't have it available to copy. And then, well, how do we get what the version should be? Well, you just run git tag because you run git tag, git stores the version, and then when you go to build, you'll actually be getting the version in your build with a couple of caveats. There's two ways to do this. Pretty much at this point, the number one way to do it would be to use Go Releaser, and Go Releaser will, well, I'll show you in just a second what it does. And the other would be Go Gitver, which is compatible with Go Releaser. So you can basically use either of these. Go Gitver runs with a Go Generate step. Go Releaser runs as its own publish step, but it will run the git tag command, and then they will embed into your program the version. And the way that they do that, oh no, we're going to come back around to that because this slide got pasted in the wrong place, so it's going to be somewhere randomly. But basically, you just define lowercase variables, commit, date, and version in your main.go, and those will be overwritten. So you can have version equals v0.0.0, date equals 000-00-00, you know, and so on. And those will get replaced when either you do the Go Generate or you do the Go Releaser, depending on which one that you use. Okay, so next thing is hello embed. So embed is when you want to have, like I mentioned this before, when you want to have a program that can do some sort of initialization sequence. So you want to say, okay, I'm going to take the example config file and I'm going to make your .config/myprogram/config.json or whatever. You want to be able to just take something that you've copied as an example template that's part of the repository, the README, whatever, and you want to be able to just fill that in. Or if you want to be able to serve some sort of UI from your application, or you have a desktop application that has lots of assets, images, etc. This is where you use Go Embed, because rather than trying to figure out how do I distribute my Go program so that it's got this directory structure and it's got a self-extracted installer, and you don't have to deal with any of that. You just include all of your assets in the binary itself, and this supersedes the old things like Go Bin Data and VFSGen, and it's a little bit more efficient because it doesn't require the use of unsafe Go to be efficient because it's in the standard library, and things in the standard library are allowed to use unsafe Go and be more efficient. So basically it just looks like this. It's incredibly simple. You just do Go Embed, and then you give it a list of files and or folders and or patterns to match. So I could do HTML/star.html, HTML/star.js, HTML/star.css, whatever, your assets. And then the file system gets the same way that you see it here is the same way that you access it. So you have a virtual file system that works exactly the same way that the file system in Go has always worked. And when you want to open something inside of this folder, you do fs.open, and you give it the HTML file name is, opens the file. So, does anybody use Go Embed? Yes!
All methods, like HTTP file server takes FS.
Yeah.
FS like there's a lot of places you can pass.
Yep. I was so glad to see it. I was just absolutely stoked when because it makes sense. It needed to be in the standard library, and I'm glad that they implemented the way that they did. You know, if you remember VFSGen, so many options, so many different ways. You know, and their thing is, look, if you want to strip the prefix, then just put the file in that directory, and that's how you strip the prefix. Get rid of the prefix by putting the generated file or the embed file in the directory. So anyway, this would be embed.go. I didn't title this, should title this. This would be embed.go. That's what that would look like. A lot of these tooling files, I think the general convention and what I do is tooling files just get their own name. It's generate.go, build.go, embed.go, so on and so forth. I don't put any code in the tool files. And then this is how you use it. So you use it exactly the same way that you would use the file system module, except that it is, I have it in some package, and I access it by virtue of whatever name I gave it. And you can give it any name. You know, the part right here, so whatever this comment is that comes directly above the next line that has embed.fs, whatever this comment is, that's what this file system becomes. So you can call this foo, you can call it bar, you can call it whatever, and you can have 10 of them. You can have
strings and byte slices. Single file.
Yeah. Thank you for that note. Okay. Oh, and then in my example project, I have a little Proverbs command that it just reads in the Go Proverbs and prints them out to the screen. So everybody should go install that. Okay. And then we're finally on to maybe one of the last pieces here, I think, which is Go Releaser. So Go Releaser's got a lot of options. It's got really great documentation, but the documentation has not necessarily got the nice TLDR that's here's what you need for 90% of use cases, and here's what you need for 90% of the other 10. And so I put a cheat sheet together on webinstall.dev. Go Releaser is installable via webinstall.dev. And I'm not going to go through all this stuff here, but whether you need a single binary, you need multiple binaries, you need cross-compilation, all those basic combinations are described in this cheat sheet, so you can just take a look. But to give you, well, first of all, let's repeat the mantra: predictable, reproducible, guaranteed. That probably should have come first. Why Go Releaser? So it'll like I said before, it'll grab the version, the git commit, and the date and inject it into your program. Oh, here we go. Here's the slide that I meant to duplicate earlier. So this is what that looks like. Go Releaser will inject this. You can give it a config file. This is a very, very simple one for a single binary that I've even culled a little bit so it'll fit on a single slide. So you can make sure that CGO isn't enabled so that you've got predictable, reproducible, guaranteed builds. You can define the binary name, say which operating systems and architectures you want it to cross-compile for, and then even do overrides so that, for example, Windows get a zip file instead of a tar file. Although Windows comes with tar.exe, the BSD version that isn't encumbered by the copyleft, which also, interestingly enough, will unzip zip files. But I would recommend for Windows, you probably want to use zip because the UI on Windows works better with zip. And I don't know if the UI works with tar files, even though the command line does. So anyway, this is what a really, really basic one would look like. And then the most important piece is that, of course, if you're going to release something, you want to release it somewhere, you probably want to release it alongside the code on GitHub. And to do that, all you need to do is go into your settings, create a token that is a release token, and then store it in config go releaser GitHub token. So then when you run go releaser, I should have actually put the full command, but I'll go back to this cheat sheet real quick because I think it's right up top here. You would run go releaser init, you'd modify your go releaser.yaml, and then you'd run go releaser, and you wouldn't run snapshot and skip publish because you wouldn't be in dev mode, you would be actually in publish mode. So you would just run go releaser rmdist, and that would build, embed all the things, run go generate, have go embed. All of the tools that we talked about would all be executed by default because that's what go releaser does. It follows the common conventions. And then you would get packages up on GitHub that have the tools that you want to make available to people. So there's that. Yep, and then the cheat sheet again right there. And then last thing is once you have go releaser set up, that's really great, because then people can go on GitHub and they can download your stuff. But then we've circled all the way back around to the original problem. Whether you're on Windows, Mac, or Linux, once you've downloaded something, you have to place it somewhere in order for it to be runnable. And on Mac, you also have to unset the, what do they call it? When you put someone in confinement, when they have a disease, you call it quarantine. On Mac OS, anything that's downloaded that isn't signed has a quarantine bit. And so if you want someone to be able to run the command that you've produced, you have to unset the quarantine bit. And this can be very difficult to explain to somebody who's a Mac user, potentially. So we have this issue of path, and we have the issue of the quarantine bit, specifically on Mac. And that is one of the things that Webby can help you with. So if you've already published a Go releaser, everything's already done. You just need something that's going to set the user's path to have your tool in it in the right place and unset the quarantine bit. And so Webby does this in a predictable, reproducible, and guaranteed way cross-platform. And there's a template repo right here. Under the dist Webby, there's the 3 files that you would need to basically just do a find and replace on with the name of your GitHub organization, the name of your GitHub repo, and then do a find and replace on the name of, instead of being called hello, whatever it is called that gets installed. And then you could make a pull request to webinstall.dev, and then you could make your tool installable as easy as is Go releaser. So basically, this is what you would get with webinstall.dev is you create the README, that is what, the TLDR, and people get a copy and paste command that's super easy to memorize, or if they've already used Webby, then they can use the Webby command. And it doesn't modify system directories like Brew does. It only installs the thing that you actually want to install. It doesn't download a huge Git repository. It doesn't have tons of helper utilities. It does have 2 small helper utilities, but anyway, so that can be a way for you to be able to actually then distribute your application. Oh, and then this was supposed to say hello Zig, but I didn't have time apparently to update that, and I don't have time to talk about, I didn't have time to prepare to talk about Zig. You're probably bored out of your mind at this point. So, but Zig is a C compiler that can make CGO cross-compilation just work. Now, there's some caveats to that, because in the situations that I've tried to use it in, the reason that I wanted to use it was that the C code was so incredibly complex that it wasn't possible to get it to compile in a reasonable way, and it had a mix of bash files and make files, and at that point, Zig can't necessarily help, because Zig isn't a bash interpreter. Zig has limitations on how much of the macro system it implements. It implements kind of the 80-20 where almost any project you come across, it can run its macros, but there are ways that you can have macros within macros. I mean, if you've ever used C code, there'll be a macro that defines a macro that defines a macro that runs a macro that defines a macro, and Zig can't handle that perfectly all the time because C is non-standard and non-portable, and there's only so much you can do. But for a lot of things, such as SQLite, Zig can give you faster, simpler, more reproducible builds of C code. So for a lot of things that you'd want to be using in Go. All right, so that is the presentation. I will open it up for questions if anybody has any. And one more reminder, like, sub, and follow if you want to, if this was interesting and entertaining for you. So any questions? I know that was kind of a whirlwind tour, but I hope that everybody learned nothing. That would be the greatest desire of my heart. But in a good way, where you already knew.
Sorry to disappoint you, but I did learn a couple of things.
So is that Zig compiler related to the language?
No, it is not related to Go at all. It's a completely separate project that is aimed at creating a better way to do really simple. It's kind of Zig is to C what Rust is to C++. So what Go is to C#, Rust is to C++, and Zig is to C.
I know a lot of people would argue with that, but I agree.
I mean, I don't think it's that controversial to say. I think that those were actually pretty mild statements. But come on, nobody here wants to use C++. You don't get out of the bed in the morning and think, oh, you know what I want to do? Pound some C++. But the Rust people, they're like, you know what I want to do? Pound some C++. Oh, it sucks. Wait, I've got Rust, right? So for people that want to pound C, Zig is an opportunity to have, Go has a runtime that's quite large, right? I mean, at bare minimum, you're looking at, I don't think you get below 4 megabytes, right? Maybe 2 if you enable the stripping options of the debugging symbols or something. But Go is really, really big. So if you wanted to implement LS, maybe Go isn't the right language to do it. If you wanted to implement BusyBox, maybe Go is. But if you wanted to implement small, tiny tools and libraries that were going to get included into C-like programs, Zig gives you the ability to do that in a very nice way. And I'll bring up Zen of Zig, because Zig, much like all languages that are good languages, Go, Python, it has a Proverbs. Let me see, Zen of Ziglang. Let's try Ziglang. Let me just try Ziglang to get to the main website. Because if you go to the main website and you go to the documentation, is it learn, documentation, language reference, down at the bottom, the very, very bottom is the Zen of Zig. And it's very, very simple. It's very Go-esque. So anybody that's familiar with the Go Proverbs should find these. Well, I mean, the Go Proverbs is a nod to the Python, the Zen of Python. It even has the same 19 stanzas and says some of the things in different words. Zen has not got all the way to 19, but you can see very similar. Let me bump this up a little bit for those in the back or the front or wherever you happen to be. So we can get down here to the bottom. Yeah. So very, very similar to Zen of Python and Go Proverbs in terms of its philosophy. So I don't think of Zig in any way being a competitor to Go. I think it being, and I know there's cases where Go's not the solution. We choose Go because it is predictable, reproducible, and guaranteed. And there are environments that are not that way to begin with, like microcontrollers or other things where you need to shave off the runtime, and you are okay to give up a few of the guarantees in order to get some of the other benefits. So totally fine to tell people at the Go meetup to check out Zig too, because maybe you got that use case.
Embedded project, you should probably reach the Russell.
Screw you, pal. Well, no, if it's truly embedded, if you're not running an operating system, then yes. Yeah, and I won't gush about Zig because we're at the Go meetup, and if there's any other questions around tooling in Go or any feedback you have, I'd love to hear that.
I think you summed it up well. The important thing for Zig for this meetup is that it is meant to replace a lot of the tool chaining to make them more predictable in cross-platform and more stripper-friendly, stripping the
It's okay, Todd. It's just you.
down banner. So it replaces all the make files, replaces all the auto tools, replaces so much stuff that you don't actually want in your tool chain, especially if you're running it on someone else's machine, like a cloud or another dev.
Yeah, and if you have stuff that you want to compile for Windows that requires C code and you want to be able to mostly use Go, then it's a good tool in the toolbox. All right. Anything else? And any feedback, because right now I'm on the backup list for Go West, and so I need any feedback that you have about what to do better as well.
I don't have feedback about what to do better, but I keep thinking about versioning because I've been like tackling that today in the project, and that's Go has like this long, frustrating history of putting version information into migrants.
That's not frustrating.
Well,
You're frustrating.
I'm frustrated. It's a great feature that Go has that you can create a variable and then the tooling can assign it a value at file time. That's cool.
That's normal.
Yeah.
Every language does that.
Yes. However, it's so nice that with Go 118 now, if you go build, it will actually put your VCS information right into the binary.
Oh, so this is new. I don't know about this.
Yeah.
Come preach.
I was hoping, yeah, automatic.
Does it follow the Go releaser standard where it's commit date and version, or did they screw it up for no reason?
So there's like you can get this from the runtime debug package. I think it's like get build info and then the settings field struct as a slice of key value pairs. I don't have to why it's a slice of key value pairs, but
I can imagine. I have some ideas.
I have to. Anyways, there are several new keys that have been added. Like VCS tells you the version control systems of Git or whatever else you're using. VCS.revision tells you the SHA.
Wait, first, where should I look for this? Should I just look in Go build?
Yeah, or
Oh, by the way, if you don't have the Go search extension, you're also living below your privileges as a member of the Go community.
so I was looking at the release notes for Go 118.
Okay.
I think you can also find in release notes for Go 118.
Okay.
The runtime. But basically, yeah, it tells you the commit SHA, the time, whether there are modifications, whether basically it's a copy of the commit or not.
That's really interesting.
Yes.
Build info. Okay.
Settings slice. And if you look at each build setting, there's again, it's a slice of kit value pairs, but
They probably didn't want to limit it because there will be new VCSs in the future, et cetera, et cetera.
yeah. So well, it's supposed to but anyways.
What part of the you have it doing it for you now located, or that it's getting?
Okay, so what I've always wanted is people who like run, let's say, patty from source, and they just do go build or go run, and they just deploy that. That's actually really common still. And when they go to file a bug, and we have them cite the output of caddy version, it gives them devel.
Oh,
Because there's no version information their build, and these are not the same people who compiled it, deployed it on their system. And so they have no idea. I have no idea, and usually it's fixed or open code, and it's all.
So what I mean, it's if you've got the solution already with Go Build and you're already on Go 118.
As of today, we set our minimum version to Go 118. So
Okay.
we Go 119.
Version of man now scrapes that data as well as the technical data.
Bill, I'm knowing that my colleague.
It don't help anybody but you'll version. That will only help you with it, right?
Well, yeah. So there's other ways to get the version though too. So like they actually embed your go.mod file in too. So you have the version of all your dependencies, but except for your main package, that's not for whatever reason that version is not embedded in your Go binary. So right now, if you want to get the version information like before Go 19, you have to file caddy or whatever Go program where its main is a, so you have to actually make a new main package and call the main indirectly as a dependency, and then you have
So this may be completely irrelevant at this point because we now have Go 118. But if you were in a situation where you were trying to protect against that problem and for some reason that methodology doesn't work, which it probably will because Go is predictable, reproducible, and guaranteed, that is what this package does as well. You just put in a Go generate, and then as part of your Go generate step, it creates a version.go.
We used to do that before we would do this very thing, right? Just, yeah, you create exported bars, and then you just replace the values and compile time, basically. And then
Yep.
Go modules, they do a bit of some version information for all your dependencies, and so the trick is to make your main a dependency. And now with Go 118, situation's a little better.
I feel like making your main a dependency is like it's just tricky. Okay.
It's kind of like the tools thing.
Yeah. You're leveraging go.mod where
All right. Anything else? I'll step down now.
Well, we'll stop the recording now. What we're saying on. You already went.
But I added it.
Yeah. All right.
All about the edit. The edit.
We all stay back and say the real salt.
All right. Salty times go.
All right.
All right. And again,
Now it's time to get salty.
is anybody else online? Like, sub, follow if you want to. Adios.